This question is from GATE 2014 Mechanical Engineering paper, set 1, question number 35. A block weighing 200 Newton is in contact with a level plane whose coefficients of static and kinetic friction are 0.4 and 0.2 respectively. The block is acted upon by a horizontal force in Newton, P is equal to 10t, where t denotes the time in seconds. The velocity in meter per second of the block attained after 10 seconds is dash. Let's write the given information first. Weight of the block is given 200 Newton. Coefficient of static friction is 0.4. Coefficient of kinetic friction is 0.2. These are unitless. Block is being acted upon by an external force P is equal to 10 times t, where t is denoting the time. T is time. And in seconds. Velocity in meter per second of the block attained after 10 seconds. So we are given t value of 10 seconds and we need to find out the velocity of the block. Let's see how it is calculated. For this block, when it is resting on a surface and in contact with the surface, because of the weight, there will be a normal reaction using Newton's third law, and that normal reaction will be equal to weight, which is equal to 200 Newton. Now, friction will act in two stages. First, there will be static friction before the motion has begun, and after the motion begins, there will be kinetic friction acting. For static friction, we are going to use mu s value, and for kinetic friction, we are going to use mu k value. To identify this point of time where the motion will begin, we will have to use static equilibrium equation first. So how do we use it? For the block, we have, if this is that block and force P is acting like this, between the surface and the block, friction is going to act in this direction, and that will be equal to mu s into n before the motion begins. So this is before onset of motion. And because now this block is stationary, we can use static equilibrium equation summation f of x equal to 0. Block is going to move in x direction. So from this we have plus p, that is in positive direction, p minus mu s into n is equal to 0. P is 10 times t minus mu s is 0.4, n is 200. This is equal to 0. From here we can calculate that time at which motion will begin. So let this time be Tm. Tm is where motion begins. So Tm is nothing but 0.4 into 200. This gives us 80 by 10 gives us 8 seconds. So at the 8th second, motion is going to begin. After which, from 8 to 10 seconds, we are going to have a moving block. And for this moving block, kinetic friction will act. Let's see how that problem is solved. So when there is motion of block, we cannot use static equilibrium equation. We will have to use Newton's second law, that is equation of motion. For equation of motion, we know that it's given by all summation of all forces, all external forces is equal to mass into acceleration, dv by dt. The right hand side is nothing but change in momentum. Now what are the external forces acting? The friction force, which will now not be mu s n, but it will be mu k n, and the force that is acting here, P. So we can write this as P minus mu k into n is equal to mass into dv by dt. Now we are aiming to find out this velocity. To find velocity, we will have to integrate. So first let's rearrange. In terms of velocity, we have dv by dt is equal to 1 by m into p is 10 times t minus mu k n is a constant. So let's just calculate this. 0.2 into, this will be 0.2 into 200, which is 40. Let's integrate from 8 to 10 seconds. So time is from 8 to 10 seconds. We'll integrate from 8 to 10 seconds. Of course, this dt has to go this side. So our equation becomes integration dv from 8 to 10 is equal to integration 8 to 10, this expression with respect to time. After integrating, we have V at 10 seconds minus V at 8 seconds, velocity at 10 seconds minus velocity at 8 seconds is equal to 1 by m is a constant taken out. In the bracket, when we apply integration, we get 10 t square by 2, which is 5t square, minus integration of 40 is 40t from 8 to 10. Let's substitute the limit and see what the velocities are. Velocity at 8 seconds. This we know that the motion has just begun, so this we can take as 0. That is why we have absolute velocity after 10 seconds is equal to 1 by m, which can be written as g by w into 5 into. So this is 5 into t square, that is 10 square minus 8 square, minus 40 into 10 minus 8, 2. Let's just substitute and find out the final answer. We have velocity after 10 seconds is equal to 9.81 divided by 200 into 5 into 10 square is 100, 8 square is 64, 100 minus 64 is 36 minus 80. This becomes 180, and the outer value, after calculating this in the digital calculator, we have velocity that we are aiming for is equal to 4.9 meter per second. Let's go back and write the answer. The velocity in meter per second of the block attained after 10 seconds is 4.9 meter per second. To learn more about friction, you can refer to the NPTEL video, Lecture 18, Friction 1 from the course Engineering Mechanics. It is by Professor K. Ramesh. He is from IIT Madras. I hope this solution will help you clear your doubt. Thank you.